All right. Hello, hello, hello. Thursday afternoon. Are you still awake? All right, let's prove this. Please stand up. And you can blame this gentleman in the front row because we just talked about this. I have to go now. Everybody stand up. Come on. It's always good to stretch. Yeah, get your blood flowing. Here we go. Very good. For those that want to, keep standing, keep standing. Make some new friends behind you. The rest, you can sit down. It's okay. Here we go. Next thing, you will see me walking on the stage a little bit for multiple reasons. I like to walk, but also I have a challenge with my wife every day. Who else does step challenges with the partner? There you go. She's already in bed because it's Europe. She lives in Europe. I am from Europe, in case you wonder where the name comes from and the strange accent. Anybody from Austria here by any chance? Any Austrians? Christi. Servus. Yeah, no. Perfect. So yeah, I have my challenge, my daily challenge with my wife, and I think today I'll beat her because she was sitting in the office all day and couldn't make that many steps. Now, today I want to talk about self-healing with AWS Lambda. I want to have a quick show of hands. Who is coding on a day-to-day basis? Who is developing? Perfect. Who is on the operations side? Who is writing configuration on a regular basis? Who is here because SRE is just the hot thing these days? It's pretty cool. Who actually has SRE in the title? Okay, cool, perfect. I have to disappoint you. I'm neither an SRE engineer, neither in operations. I do code. What you will see from me today is Lambda code. Maybe not the prettiest, but you see Lambda code that I wrote to actually hook up AWS code pipeline with my monitoring system to stop bad code changes from flowing through a pipeline. I'm also using Lambda functions to trigger self-healing or self-auto-remediation actions. And I'm automating a couple of things that I've seen out there in our own organization, the way we do SREs, the way we do self-healing, and also with a lot of the larger organizations that we are working with on a day-to-day basis. The agenda, remediation use cases. I want to talk a little bit about the things we see out there to get you a little idea on what I believe we can kind of remediate in a more automated way. We talked about this. What's your name, by the way? Glenn, right? We talked about this. You're doing this already for many, many years on your database side. Now you got bored of it, and now you try to do this in the cloud. So you said self-healing is definitely possible, right? Not only on the database side, on the application, the cloud. I agree with you, and I'm sure there's many more use cases that we can automate. I'll just give you a handful. I am a strong believer, though, that self-healing, and hopefully, Glenn, you agree with me, should not be done only in production. We want to prevent as many things as possible. So prevent versus repair is much better. I want to show you auto-remediation as code, a concept that I believe we should all teach and mentor every developer. So if I am a developer, I should not only write code, I should also obviously write, code as code, test as code, configuration as code, auto-remediation as code. I should also write what should be happening in case something is wrong. And then at the end, I want to introduce you to something that's called the unbreakable delivery pipeline. The idea, actually, the idea of that came to me last year at re:Invent. I watched a session from Curtis Bray, who showed me AWS code pipeline and some advanced concepts. And then I came up with the idea of extending his concept and making sure that if you build a pipeline like this, you cannot push any code or configuration changes through a pipeline that in the end impact users or impact your SLAs. That's the whole idea. All right? Good. So remediation use cases. I picked a couple use cases that I've seen out there in the field. Who has seen processes crashing? Right? You see processes crashing all the time. If a process crash, what can we do? Restart. We can write scripts for that, obviously. Very simple use case. Another one, full or slow disk. Who has seen full or slow disks? Slowing down things, crashing things, right? We've seen this. So we can do a lot of things to make these problems go away. We can either do it through batch jobs that run on a continuous basis and scrap things and clean things up. We can trigger it, hopefully not too late. Another thing, bad configuration changes. Who has made a configuration change and thought everything is safe, and afterwards it turned out it was a disaster? Yeah, exactly. We've been there, right? Like in this case, you can see a deployment of a new WAR file, a new Java application, and at the deployment time, we immediately see the response time going through the roof. Obviously, some developers thought the code changes are really smart and fast, but it turned out to be not that case. What else do we have? Another bad configuration change. Change in the DNS routes incorrectly. Unfortunately, the website no longer accessible, right? That's a configuration change that has a huge impact, a very visible impact. Has anybody run into this problem? Yeah? Never ever, right? We can also say, I am Andy, and I am bad in configuration changes. Next thing, who has low on resources? So what you see here on the left side, on the top, a service that currently runs on 2 processes or 2 containers. And then, if with increased load or whatever else happens on the system, when you run low on resources, having the ability to scale up. Now, obviously, we have auto-scaling groups, but auto-scaling groups, I believe, cannot handle every single instance or every single use case why you want to scale up your resources. But a very easy one that can be obviously done with auto-scaling groups is CPU. But hopefully, you don't scale endlessly, because if a developer, and I know there's developers in the room, I'm also a developer, so I kind of bash myself. If you are checking in code that is very CPU or memory aggressive, and you just have auto-scaling groups, right? AWS will be very happy about it, obviously, because they sell a lot of more resources. But this auto-scaling should only go that far, and then eventually you want to do something else and fix the problem. Another scenario is the opposite, right? If you're over-provisioned after a drop in traffic, you want to scale down properly, right? What else do we have? Blue-green. Who is doing blue-green deployments? Perfect. By the way, can you show me this again, blue-green deployments? So in case you sit next to somebody that just raised your hand and you always want it, I want to do it too, but I haven't done it. Just, after the talk, turn around, yeah? So you raised your hand. The people that didn't raise your hand, maybe you want to say, hey, shall I tell you a little bit how it's done? What we can do, obviously, is figure out blue versus green, what's better, and basically, faster move over or reverts the traffic in case the new version doesn't work as expected. What else do we have? Another way of figuring out if blue-green deployments are actually good. Right? In this case, again, similar situation as earlier, where the deployment of a new version caused a complete drop in conversion rate. If you think about an e-commerce store, obviously not a good version. Now, these were a couple of lists. It's a small list, right? Glenn, I'm sure you have many, many more in your life, especially on the database side. And I'm sure if I ask the room, what are the typical actions that you can remediate, then the list goes on and on and on. Just a couple. What I've seen, and I know some of you in the room here are more advanced. If I look at you that just raised your hand with the blue-green deployment, right? You're obviously not the one that is doing things manually. You already have automated everything. Yeah? Some may not, right? Or some may don't want to admit it in the room next to others. But I've seen companies and organizations that have not yet automated everything, or just maybe semi-automated. Now, what I want to talk first off, instead of telling you how we can fix these problems in production using Lambda functions, I first want to talk about prevention. And when I talk about prevention, I want to start with the code and configuration change that is made by the developer or whoever makes code and configuration changes. Right? If you deploy a change into a staging environment or whatever environment you have, hopefully you have some quality gates. Most quality gates, I think, are around security, your unit tests, your functional tests. You may end up pushing this code change into production, and then you have your end users that are hopefully happy. Right? But if something happens later down the line, like what you saw earlier, bad code change, results in high CPU consumption, results in the websites get slower, people are getting not so easy, you can see the frowning face now, then I wonder what can we learn from this besides trying to figure out how to fix this in production, but what can we take out of this? How can we figure out how we can add this particular use case into an automated pipeline, into a quality gate? Right? With your database experience again, I'm sure you've seen bad SQL code, index is missing and all that stuff, right? So I'm sure if you see a problem in production, then you want to figure out, okay, how did you figure this out? How can I replicate this problem in a pre-prod environment so the next time the developer makes the same mistake, it is automatically blocked by the pipeline. That's what I try to get to. So a couple of examples here, use cases and metrics that I believe we should shift left. So one of the things that I see very often, especially when talking with or working with application developers, is bad log behavior. Right? Who has seen disks being filled up by huge log files? Okay, keep your hands up. Who of you actually went to the developer and showed them the log file and asked them how much of that is actually useful information? Okay, most of you. And then what did you get back? Every log message that was in there was valid and legit and very informational? Not always. Right? We'll get back to you. Yeah. Yeah. Turned on debug, verbose logging, something like that, right? And forgot to turn it off in production. So what I'm proposing is, if you see these cases in production, then become mentors to whoever is responsible for your development teams, for your CI/CD pipelines, and figure out a way how you can measure the number of log messages, the amount of log size overall in your CI/CD, in your tests, and measure the size from build to build to build. And if a developer makes a code change, like the debug log, changing it to debug log, and all of a sudden the log volume for a test goes from 1 megabyte to 10 megabytes, you want to say, I'm sure your code is awesome, but something is wrong. Unless these additional 9 megabytes are legit and you need it, right? So, and there's a lot of things that we can do, right? What I try to do here with and by the way, the slides I believe are shared and the recording is online. I see people taking pictures, that's great. But I always try it with my use cases. The use case, the metrics, how to query it, there's different ways. I just gave you an example. But try to figure out how to bake this into a pipeline. Next example, detecting change in resource consumption. The classical, what I brought earlier, CPU, or maybe also memory. Same scenario. If what we've seen in our organization, upgrading to a new log framework, updating to a new OR mapper, right, a new version. We actually had the case where the vendor told us we have to update the library because our version right now has a security hole, so we upgraded it. Unfortunately, that version that we upgraded to had a memory leak, right? And we blindly followed the rule without having an eye on the memory usage of this library. Now, if you bake this into your pipeline, you can detect these problems early before they kill your production. Right? So a lot of ways to query this information. Detect changes in dependencies. Another example that I see more and more now as we're moving to more smaller services, whether you call them microservices or I don't care what you call them. But the idea is if you are building or you're componentizing your systems, you're building microservices, and then you think, hey, there's a new service out there, I'll just call it, and there's another one here, and I call it, and make a code change or configuration change that introduces new dependencies, then often it happens consciously, but it doesn't often happen consciously. Sometimes it happens because you are making a configuration change that has an unintentional brings in unintentional additional dependencies. So what I'm saying, what you should do is try to figure out how you can validate the number of incoming and outgoing dependencies when you are pushing your code changes through the pipeline, right? What else do we have here? Oh, and one that I love a lot, exceptions. Who loves exceptions? Being logged, stack traces, endless. Very useful in cases, but not always. What we are always looking out for is how many exceptions are thrown in the application and not necessarily logged. We talked about logging earlier. Not every exception in a Java or in a .NET application actually sees the light of a log. Most exceptions are thrown, are catched, whoever what they do with it. Most exceptions that we see happen in frameworks. Thousands and millions of them, never seeing the light of a log file, but consuming a lot of resources. Every exception, I'm not sure, where are the Java developers in the room and the .NET developers? Any Java developers? Come on. Here we go. Every time you create an exception object, the JVM fills the stack trace. Right? It's a lot of memory that also needs to be garbage collected later on. And therefore, What we are always looking for are JMX metrics or any metrics that your runtime exposes or your monitoring tool exposes that tells you how many exception objects were actually created and thrown. Not necessarily which exceptions made it to the log file. Very important. Make sense? Well, a little bit? Cool. Maybe I need to make you stand up again to get your blood flowing. All right, what's the next one? Change in performance behavior. Right? Again, bad code change maybe, change in performance behavior. What we are looking at here is obviously response times, but also throughput and performance per instance. Who is doing canary releases, right? So what we are monitoring, what we try to do is actually figure out, and it's a little hard to see maybe here, but every line here represents maybe a container instance. One is blue, green, canary 1, canary 2, and try to figure out if you get the same throughput through canary A versus canary B, or CPU and memory consumption. Right? You do not only want to test or look for performance, but also resource consumption per canary, and then immediately alert in case something is wrong, something is abnormal. Detecting change in error behavior, right? Your classical HTTP failure rate analysis, JavaScript error rate analysis. I hope all of you that are building and working on any applications that an end user can access through a browser or a mobile phone are using functional tests. Yes, no? Yeah? Make sure if you're using tools like Selenium or any other tools that drive a mobile device, that you also figure out, are there any hidden JavaScript errors that maybe are not visible to the end user, but still, if they are thrown, it means some part of the application might not be functional, even though maybe your test doesn't see it, because maybe you're not testing this particular piece. But we're always looking at number of JavaScript errors that come in as well. What else do we have? Detecting change in user scenarios, that's a big one. Figuring out how many interactions does it take to fulfill a certain use case. Right? If you think of Amazon, if you buy something on Amazon, you go to the website, you log on, or you hopefully automatically logged on, but you search your products, you put it into the cart, and there's a one-click checkout. If they change something in this workflow, and now you have 1 or 2 additional steps, that means you have to spend more resources per end-user flow interaction, which means, first of all, I think it's not nice for the end user if things take longer, unless it's really intentional. But it really means more resource consumption on your server side. Right? More interactions, more images that they download. So therefore, what we always look for is when you run your functional tests, look at things like total page size, number of resources, number of requests being sent back and forth. Also check if your images are compressed, if all of these things are taken care of. All right, so showed you a list of metrics. Again, the number is by far the list is by far not complete. Glenn, I'm sure there's a lot of metrics that I missed here, especially on the database side, for instance. The number of interactions with the database, the classical behavior where a developer makes a code change, maybe uses an OR mapper that is kind of shielding the database interaction, but then through a configuration change, changes from lazy to eager loading, making too many round trips to the database, the classical n+1 query problem where the same query gets executed hundreds and thousands of times. Right? These are things we can detect in the pipeline automatically. All right, so how can we add this to the pipeline? So basically what I just showed you, I can take these use cases. Now I gave you a handful. I hope when you find problems in production and you know how you detect it, what you looked at, that you can automate that into the pipeline. So figure out how you can grab these metrics, this piece of information, and then tell and ask the folks in the organization that are responsible for the pipeline to bake it into the quality gates. And for AWS, is anybody using code pipeline? AWS code pipeline, yeah? Who's using Jenkins in here? All right, perfect. Whether it's Jenkins, code pipeline, Bamboo, Concourse, we have the concept of quality gates. So make sure you capture these metrics and validate them. So now, to my part, what I've implemented. This is the inspiration I got last year from Curtis Bray. The session is online, obviously, and he basically introduced me to the concept of how I can actually use Lambda functions in AWS Code Pipeline to, while the pipeline runs, reach out to other tools to figure out, are we meeting certain quality criteria. He was actually showing it by running a functional script. He was using, I believe, Selenium. And then as the pipeline ran and Selenium started running on the, behind the scenes, he was actually interrupting the pipeline at the time when Selenium said something is wrong, right? And he introduced me to that concept on how we can do this. And what I've also done, I have looked at Thomas Steinmauer is one of my colleagues and also somebody that I look up for or up to. He's the chief performance architect at Dynatrace. And what he does, we are using Jenkins internally. So what he does every day, he runs a set of load against the system in staging. And as you can see here, on, what's the date here? It is November 16 and 17, right? He always runs load against the system. And he says, Andy, when I look at my data, well, first of all, I stopped looking at it manually, I automated it, but when I look at these metrics, the number of log messages written, the number of database interactions, the performance, the throughput, then I typically have a set of metrics that I'm analyzing for a particular piece of our software architecture. And it's different metrics. For some, it's more response time and resource related. For some, it might be something else. But he said the set of metrics is what I call the performance signature. And what he does, he says, I basically look at key metrics from build to build that I always push through the pipeline, where I always execute the same amount of load. And in case I see a regression, I know something is wrong. And the way he actually does it, he's evaluating the performance signature for every build. So the line here, or the column, is basically a build. The one highlighted is the one from January 13. So he evaluates the performance signature of every build. He has multiple metrics that he's validating for every build. And in case there is a regression to the previous build, so for instance, the number of log messages goes up, or the number of database interactions goes up, then he, in this table, he obviously displays the value, but he has like a little heat field. Very simple, but he can look at this dashboard and immediately sees if there's more red than there should be, and then immediately notifies the developers. Now, he's not looking at this anymore every day. He automated that as well. So what he actually does, when there's a certain percentage of metrics that fell over, he's automatically creating a Jira ticket. We're using Jira internally, and assigns it to those developers that made code changes in the last 24 hours on the component that he's testing. And he's then adding a link to this dashboard. So a developer comes in the morning, knows his code that he changed yesterday was just battle tested overnight, and he sees that 20% CPU increase, 50% more log interactions, 50% maybe more database interactions, and then they get a Jira ticket. Now, I like this concept. He implemented this several years ago, and I thought, how can I replicate this in a way that we can easily use this, for instance, in an AWS environment? So first of all, what I did, I came up with the notion of the term monitoring as code. So I said, it's great if I have somebody like Thomas that knows which metrics to look at, but Thomas, if he, like in our organization, we have 700 developers, and we have a lot of different development teams. He cannot go to every individual developers and sit down with them and say, what metrics do we want to validate? What he can do, he can mentor them and say, hey, I need to pick somebody else now. What's your name? Andrew. Hey, Andrew, you know best which component you develop in. You probably know best if you have any SLAs and requirements for response time, memory, dependencies. Andrew, you just write a JSON file or a YAML file and just list which metrics are important for you, what your SLAs are, how you want to compare it. Do you want to fail if you're 10% over a certain limit? So I took the same concept. Basically, I call this MonSpec, monitoring specification as code. You can see performance signature, time series, which aggregate, average, min, max, 90th percentile. And also what I have on the bottom is dependency metrics. Now, these are metrics that I get from my monitoring tool. and again, the way I implemented it as a first use case is with Dynatrace, but you can, I'm sure, whatever tools you have, you can do something similar. But the idea is put it into a config file. All right, what do I do with this config file? The way I've implemented it, I'm using code pipeline, and then in my code pipeline, after I deploy my build, after I deploy or start my tests, I have a Lambda function that is called register build validation, register Dynatrace build validation in this case. And what this does, Andrew, right? Or Andre? Andrew, okay, perfect. What this does is basically when you are pushing this pipeline, you say, my build just got deployed, we're starting some tests that may run a minute, maybe 5 minutes, maybe an hour. I want to register this build to be validated against my performance signature. Okay? Now, I have a question for you that for those that already wrote Lambda functions and that have seen hopefully code pipeline or have an understanding of a pipeline. If this pipeline runs through, I deploy it, my build, I start my tests, and then I say register build validation. If these tests, let's say, run for an hour, and then I say I wanna do some validation. If I call this Lambda function, a Lambda function is probably or Lambda functions are not intended to run for like an hour, right, to wait. Agree or not? Right? Agree. So this is why, this is actually the concept that Curtis Bray involved me to, but this is why I called the Lambda function register. So I basically say I have a build that is currently being tested and I want something else, somebody to have a look at it. Maybe it's somebody manual that looks at dashboards, or I built some automation around it. So this is what I built. This is again, thanks to Curtis. What actually happens, I call my Lambda function that says this is the code from you with your monspec file with all the information, what is actually the build, which microservice. And what I did, I write all of this information into a DynamoDB table. So this is my request. In the old days, maybe I sent an email to Thomas, right, my colleague, and I say, Thomas, I just started my pipeline. Have a look at these dashboards and tell me what you think. Now I basically write this into a DynamoDB table with the monspec file, the current time frame, also what I want to kind of compare and what I should do in case I eventually, or whoever is taking care of it, approves or rejects it. So I write this into a table, and then I'm using CloudWatch events because in this case I'm automating Thomas away. I'm using CloudWatch events. I'm using CloudWatch events to call every minute another Lambda function that does the following thing. It goes up and pulls information from the DynamoDB table and says, did somebody like Andrew put in a request? Yes. Did enough time pass? Because what you can also say, right, you cannot start validating right after the first minute. If you run especially loader performance tests, you want to at least go through the first 10, 15 minutes. So I'm pulling it down and I say, has enough time passed so that I can start my evaluation? That's great. Andrew said, wait for 5 minutes and then start evaluating. If time is right, the Lambda function parses your config file, pulls in all the metrics and the data from the underlying tools. It might be just one tool, it might be many tools, and then writes back the results. And what it also does, in case there's something wrong, one of the metrics goes out of whack, I call back to the pipeline that is actually sitting here in the approval stage because the pipeline starts running, I deploy the app, I start my tests, I register my build, and then the pipeline keeps staying here in the approval stage. And this is normally a manual step. But now I automated it because this is my build validation function. Yeah? And I think why this is cool, it's for multiple reasons. First of all, I just automated a manual step. But if you think about a longer running test suite, let's say your tests run for an hour or 5 hours, what this Lambda function can do, it can say, hey, Andrew, he wants to validate my build. He says, wait at least 15 minutes. He also told me, or I know from history, that the builds, that the tests typically run an hour. But you know what I do? I'm smart. Because already after 15 minutes, I start looking at all the metrics. And if I see after 20 minutes that the disks are already getting full, I already have a regression, I immediately stop the pipeline. Because there's no need to keep the pipeline running until all the tests are complete. Does it make sense? This speeds up also your pipeline execution. All right, so this is how it then looks like in how I implemented it, and I'll show you a live demo in a second. So in case everything is great, I approve the step, and in case it's not good, I reject it, and then I put a link in there that actually brings me to a dashboard that I also built. So the DynamoDB table that I was talking about, where I put in the request and also sent back the results, I basically built another Lambda function that is then just visualizing the data. So that means I actually see every row here is a metric, right? And every column is a build. So I see my individual builds, and I also see in case one of my metrics goes out of what I want. Right? So it's also a nice visualization, a nice history. Now the reason why I had to build this also, like why I'm doing this like this, I really like code pipeline. I however, personally have other favors when it comes to CI/CD tools. I would wish that we can get something in code pipeline where this is kind of like natively built into the pipeline, where we have build artifacts or build results that can be visualized, that I don't have to build my own thing, but it works actually pretty easy, all right? So let's have a quick demo. Let's flip over here. Let me duplicate this here. All right. So I got my pipeline, and actually I uploaded a new build earlier. Sure. So I let it run while I'm talking. So the pipeline, as I said earlier, is really, really simple. It's a microservice. It's a Node.js microservice. I'm deploying my build now. Then I'm running my tests. Then I have my register build validation. And in the back, what happens, I shall show you a couple of things that I mentioned earlier. Let me quickly go to my DynamoDB. So every time the pipeline runs, and let me just go in here a little bigger, right? Here's my build validation requests. This is my table. I got my items in here. That means every time I run my pipeline, I have an entry in my table that says this pipeline at this particular timestamp has asked me to approve staging or a production. So these are different stages in my pipeline. What else do I have here? I have my monspec file. I'll show you that in a better editor later on. And yeah, these are, I think, the most important things. Now the monspec file, this is what I talked about earlier. Just zoom in here a little bit, right? This is basically my file. It says I want to validate the average response time. I want to have the 90th percentile. I want to have the failure rate, requests per minute. And then this is a favorite for me. This is the to and from relationships. So my monitoring tool automatically detects when I deploy my app and I run my end-to-end tests, it understands how many calls are coming in from this service, maybe from the front end, from a front-end component or front-end services. How many calls does it make to other services like a database? And also how many containers, for instance, does it run at a particular load level? So I can actually use this information for dynamic architecture validation, as I call it. And I can not only do this overall for my service, I can also do this for my individual endpoints, right? For my individual service methods, like API/invoke. Maybe I have different performance criteria, different metrics I want to evaluate for my individual endpoints. So the monspec file that lives in my source code repo. And then let's see how my pipeline is running. My pipeline deploying, here we go. See, my pipeline deployed. It says deployed tests in staging. Deployed tests sounds strange. Started my tests. I actually started a test that runs for a couple of minutes. And then I have my register staging validation. So this is the Lambda function that I'm calling. And by the way, all of this code is also on GitHub, and I'll give you the link later on. And I just noticed that obviously the screen resolution might be, let's see how fast this works. Sometimes you gotta be patient, and sometimes I am not. All right. Sometimes you just have to close the window and open it again, right? So here's the Lambda code that is actually figuring, I can call my Lambda function from different sources. If it is called from the code pipeline, then I capture additional information. Which code pipeline is it? Which particular step is it? And I push all of this information into my database, right? Into my DynamoDB. So don't want to go through all the source code. Everything is here. Feel free to just use the same thing. And I'll give you the link in a second. So this is the Lambda function that was called for register staging validation. Now you can see here, now my pipeline is waiting for approval. I can either manually approve it or behind the scenes, I'm using CloudWatch events, and it calls another Lambda function. And it is the, if I go back, wow, this is really hard to navigate now. If I go to my services, Lambdas, I have my validate Dynatrace build worker. So this is the one function that gets executed on a regular basis. And basically what it does, it says, it starts off with, is there any build right now that needs to be validated, has enough time passed, and if so, then I'm doing all of my validation. Then I'm reaching out to all the different tools that you told me based on your config file. Okay? And last but not least, I have this overview here, right? This is now what you saw earlier in my screenshot. This is nothing else than I'm calling another Lambda function that is giving me a visual representation of the data that is in my DynamoDB table. Every build request from the past. I know it doesn't look sexy. I'm not a front-end developer, but at least, it's good enough for me. Right? And I saw I had a bad build here earlier, and what I should see, because the pipeline that I'm running right now is actually a build that has a little performance problem, and it should actually stop the build. But I told my Lambda function at least wait for 5 minutes until enough load has been generated. So we'll come back to this in a second, because I know we have about 20 minutes left. By the way, questions, happy later on. Just extend this for you again. All right. But the idea is that the pipeline will stop. So, next thing, I believe, unfortunately, and Glenn, you can probably agree with me, we cannot stop every bad code or SQL statement change in pre-prod. We try to, but we can't. Certain things flip through. Get rid of people. Get rid of people. Okay. I think we should talk later on. All right. One of the things that I got one of our customers where I got inspired from was Eric from Beachbody. I met him last year, and we talked about how we can self-remediate and what we can actually do in case things go into production. And he said, well, when he started at Beachbody, I think it was like now 3 years ago, he was signed up as the head of operations. And he had 2 people, and they were all watching it. They had all like huge monitors in the room. They were all red. Nobody cared, because they said, we don't even know what this means because we didn't build it. And we have to spend too much time to actually deal with the 10,000 emails of alerts that we get in every day. So he said he wanted to convert that operations team into an SRE team. Right? He wanted to get completely rid of any dashboard, of anything that is red. He said we should be able to automate it. So the first thing that he obviously started with is ChatOps, because he still want to be notified of things, especially these new problems that come in that they need to first fix, then learn, and then figure out how we can auto-remediate. I want to show you a use case that I kind of walked through with him, and I understand now, if I look at it, this is really small. But what you see here is modern monitoring tools and alerting tools. They give you alerts that tell you something like, here is the application that is impacted. It also tells you, in my case, this is actually, we were monitoring our own website. It says Dynatrace.com is currently experiencing JavaScript error rate increase in production. It only impacts users that are using a desktop browser on Windows 7. So the monitoring tool is smart enough to tell me it only impacts Windows users, and I know that not many people care about Windows users, but we care. But at least I know what the kind of blast radius is. So if we get a problem like this, the first thing we can do in, I would say, classical operations in incident management, we can inform the web team there's obviously something wrong with JavaScript on IE. Maybe they deployed something, maybe they brought in a new library, and they didn't run any of the functional tests on IE. You can push a status update information to inform the customers that something is not right now, and maybe also inform our support about potential incoming calls. But more importantly, and what you see on the left here, is we can look at a lot of more evidence that goes into that problem. So for instance, what was the last deployment and configuration change that was made? What else happened in the system? Maybe the configuration change actually caused a disk to become full because the configuration change changed the log level to debug or verbose. Right? So we have all this information in there, and therefore what I've been working with Eric from Beachbody and others, trying to figure out how can we now call not people at 2 o'clock in the morning, but call with, for instance, Lambda functions or Chef scripts, Ansible scripts, whatever you want, or even another pipeline to then address the real problem. Right? So for instance, CPU is exhausted because at the same time we had a spike in load. So maybe we just add a couple of additional instances. Maybe there was an exhausted connection pool to your database because they added a new feature, and this feature is not as good with the database connections as the other features they had before. So maybe we need to increase the connection pools. We can do this on the fly automatically. What?
Just had that situation 2 weeks ago.
Yeah, I just 2 weeks ago. You wouldn't have this problem, obviously, if we wouldn't have people, right? To come back to what you said earlier. Without people, we wouldn't have this problem. But without people, we wouldn't have innovation. It would be a little boring on this planet. Or maybe there was a canary, there was an issue that's just happening on the canary release. Well, let's redirect traffic fully automatically. And if this problem mitigates the impact, we can obviously, again, update our teams, right? Tell them that everything is been taken care of. If it's still ongoing, obviously, you can still escalate if this is really a big issue. But this is kind of the thing that it's kind of the use cases that I've been promoting. And the way I've implemented this in the pipeline, what you haven't seen earlier is one additional step that I had in my pipeline that is called push Dynatrace deployment, or push deployment information to my monitoring tool. That means I tell the monitoring tool additional context. I say, it was Andrew, he deployed that build, or maybe your boss signed up for it, but Andrew is a good guy. He's a good developer because he's writing tests and he's writing Monspec, but he's also writing auto remediation scripts. So he actually has written a Lambda function, for instance, that we should call in case something is wrong with his deployment. So that means what I'm pushing over here is actually another Lambda, link to a Lambda function, or a webhook basically, that the monitoring tool should call in case there's a problem with your deployment. Okay? So code as code, test as code, monitoring as code, auto remediation as code. Everything lives in your Git or AWS code commit or wherever it is. And we push it over. So that means in case a problem is detected, so this is now a screenshot from our product, problem is detected, we are actually not just sending emails, but we're calling a Lambda function. And then the Lambda function, in my case, is pulling down additional information from the additional context that we send over to the monitoring tool, and then is executing, for instance, a rollback, a scale up, a scale down, whatever it is. And then also sends back information to the monitoring tool or to your incident management tool that you actually took course correcting actions fully automatically. All right. So here's a screenshot that I just took earlier this morning, but basically this kind of shows it nicely. I have my Node.js service that had a failure rate increase. It exceeded my threshold of 0% failure rate. Dynatrace immediately detected that the root cause was actually a deployment. On that deployment, I have my remediation action. The remediation action was automatically called, and the remediation action also commented that, hey, I just created the new deployment. So I kept the impact rather contained. All right, so let's quick demo and see how this looks like here. So by the way, first of all, before I show you that demo, my pipeline failed earlier, right? When I ran the build, I actually pushed a build through that actually had an issue. Now it failed the build. I can click on details and it says, hey, one performance signature violation found. Please check the results in the DynamoDB or simply go to that link. This is what my initial Lambda function pushed back. So I can open this up and then here we go, right? This is the latest build. I can see that the failure rate increased like crazy, and this is the reason why my pipeline was automatically stopped and this build was not promoted further in production. And if we look at this production problem that I showed you earlier, so this is the problem I had open in my screenshot as well. Right? This is the information where, as part of the deployment, when my pipeline actually deploys the build, go back to the pipeline, it's this Lambda function here, push deployment event to Dynatrace in this case. It's just another Lambda function that also knows which Lambda function to call in case something is wrong. All right, cool. All the source code is also available, by the way. AWS DevOps tutorial is available here. It's called AWS DevOps tutorial, including a CloudFormation template. It's a sample app that is actually, I made it available in multiple builds. And you can play around with it, right? I understand that you obviously have your own environment, your own apps, your own problems, whatever tools you use to capture these metrics. I don't care. What I care about is that I believe we should all change, right? We should not just think that we, if you're on the operations side, should stay on the operations side forever and just talk bad about the developers. We should figure out how we can change our engineers, right? And I'm also an engineer, right? We need to enable them to start writing proper tests, monitoring definitions, what is relevant for them, also auto remediation, baking it into a pipeline that makes sure no bad code changes can ever impact your business, right? So, and then the last to kind of finish it up here, let me just go, yeah? So so you're talking about how can we do non-functional requirement? I think before.
Say for instance, the same software, a new build.
Yeah.
There's a new non-functional requirement that is causing some extra cost or
yeah.
some other performance which are genuine.
Yeah. So that means if it's an intentional change in this monspec file that I was earlier educating Andrew on writing, you can also specify with a new build that this metric is allowed to change because you know you're adding a new functionality. So you say, I understand that we have a new dependency. And the reason why this works is because this monspec file lives in your source code repo. It gets versioned. So with every version you build, you also update, just as you update your tests, you update your monitoring specification file as well. And you say, I want to validate that I'm actually connecting to this database, but only to that, not the one in production, maybe just here, right? All right, so let me finish this off. I see before people leave and miss the best part, my joke in the end, which, by the way, I'm Austrian, we don't joke around. Right? So, in the end, the unbreakable delivery pipeline. This is kind of bringing it home and kind of showing the end-to-end use case, what I just showed you. I am a strong believer that we have great monitoring tools out there, great diagnostic tools out there, great security tools out there. Just make sure that you leverage them. And leverage them in a way that they actually solve a real problem that you potentially have in production. And for those of you that are in operations, and Glenn, I look at you again, I know with the color of your beard, I understand you have a lot of experience, right? That means you are the perfect person to teach and mentor the next generation of software engineers on what to take care of, right? And help them to build this into the fabric, into the pipeline. So that means every time I deploy a new build, figure out how you can compare these key metrics from build to build and act as a quality gate. If you deploy into production, validate that your production also runs as expected. What I also say here, I think this is also a perfect spot to validate actually your auto remediation functions or your self-healing functions, right? If you deploy into an environment like a pre-prod environment where you can run, or you can simulate production-ready load. You can also then do chaos monkey, you do some chaos monkey testing and actually validate, does the remediation function from Andrew actually work in case something blows up, right? I think it should not be tested the first time in production. And if you do this, and then in the end you have happy users, right, as you saw them earlier, and then something happens and they're unhappy, then we can call the scripts that have already been battle tested in our chaos monkey environment, and we know that you don't break anybody out there, any experience, right? So with this, I want to say thank you. I hope I sparked some new ideas on how we can not only solve a problem in production by building a lot of automation scripts that fix production problems, but first starting to prevent them. Right? And whether you do use Lambda for the glue code in between your pipeline, and your systems where you deploy, or something else, that's up to you. I believe Lambda, especially in an AWS environment, is a pretty natural, logical decision. And really cool, really flexible. All right, that's it. I give you 9 minutes actually, 9 more minutes. But in case I will stay here. For those people that want to leave, you're free to go. For those people that have questions, I think I still have 9 minutes for questions.